Hey everybody, welcome back. Today we're going to talk about how to estimate a limit value from looking at a graph. Okay, so first let's talk about this notion of one-sided limits. What does that mean? That means only looking at a point, just approaching it from the left side or the right side. If we want to find the limit of a function as x approaches some value of c from only the left-hand side, this is how we will write that. Okay, it looks almost exactly the same as a normal limit. The only difference is this little negative sign here in the superscript. Okay, so we say the limit as x approaches c from the left of the function. Same thing is true if we want to approach the c value from the right. The only difference is we change that negative sign to a positive sign. So this would be the limit as x approaches c from the right of the function. Okay, in order for a limit to exist, those two one-sided limits must be equal. So if the limit from the left-hand side of the function and the limit from the right-hand side of that function at c are the same number, then that limit exists, and we say that limit is equal to some number L. All right, so let's take a look here. Very important. A little note at the bottom of this slide: in order for a limit to exist, the function must be approaching the same y value as the x approaches some value c from either the left or the right side. If this has not happened, then we say that the limit does not exist. We write dne as x approaches c. So here are some examples. For each graph of the function f, find all required information. We have an example one here. We have a piecewise function. And question A says, what is the limit as x approaches 1 from the left? So as x approaches 1 from the left-hand side, where is y trying to reach? It's trying to reach this point right here, which is y equals 1. B says, as x approaches 1 from the right side, so now we're going this way, what y value is the function trying to reach? And that is trying to reach this point here, which is 2. Pretty obvious that the left-hand limit and the right-hand limit at 1 do not agree. Therefore, we say the actual limit does not exist at x equals 1. And then D says, what is f of 1? So what is the y value at 1? Well, that's the filled-in circle there. So that's 2. Example 2. What is the limit as x approaches 1 from the left? So what are we trying to get to? We're trying to get to this point right here, which is negative 1. But as x approaches 1 from the right, we're trying to get to that value, which is positive 1. Again, pretty clear that the left and right-hand sides don't agree. Therefore, this limit at 1 does not exist. And then the last question, what is f of 1? F of 1 is that point right there. F of 1 would be 0. Example 3, as x approaches 1 from the left, we're trying to get to 1. As x approaches 1 from the right, we're also trying to get to 1. That's all that matters. Those two agree, therefore the limit exists, and our answer is 1. The fact that D says f of 1 equals, and it also happens to equal 1, doesn't really mean anything here. Okay, as long as these two agree, this is true. This does not impact that. Number 4, as x approaches 1 from the left, again, we're trying to reach 1. As x approaches 1 from the right, we're again trying to reach 1, and that's all that matters. Therefore, our limit does exist, and our answer would be 1. The fact that f of 1 does not equal 1 here doesn't matter. F of 1 is negative 2, as you can see from that point right there. Remember that a limit is just a height or a y value that a function is trying to reach. Whether it reaches it or not does not mean anything. Both sides are trying to reach 1, therefore the limit is 1. Example 5. As x approaches 0 from the left, we're trying to get to 1. as x approaches 0 from the right, the y is trying to reach 1. That's it. The limit exists, and it is 1. What is f of 0? Well, that's also going to be 1. But again, that doesn't really matter. All that matters is that a and b agree. As x approaches 2 from the left, looks like it's going down to negative infinity. As x approaches 2 from the right, we're going up to positive infinity. So since those two don't match, we say that limit does not exist. And what is f of 2? Well, there is no value at f of 2. There's a vertical asymptote there, so we say that one is undefined. For number 7, as x approaches negative 2 from the left-hand side, that's negative infinity. As x approaches 2 from the right-hand side, that's negative infinity. Since they both agree, we can write negative infinity there as long as we understand that an infinite limit actually does not exist. Right? They're opposites of each other. Infinity and limit, you can't limit infinity. So if we say the limit actually is negative infinity, that means that that limit does not exist. All right, and finally, what is f of negative 2? That would be 0. Okay, so now we're going to take a look at using a graphing calculator or some type of graphing device. We can use the graph or we can use a table to find each limit. So the first one says a limit as x approaches 0 of this function here. Go ahead and pause this video if you need to put that into some type of graphing device and come back and unpause it when you're ready. But the graph is going to look something like this. So using our graph, we can see that from both sides, we're trying to reach 2. Example 9. Okay, this is a piecewise function. We shouldn't need a graphing device to graph this one here. It's just a horizontal line everywhere but x equals 2, and then the point 2 comma 0. So let's plot the point 2 comma 0 first. And everywhere but x equals 2, we're going to graph the line y equals 1. So as we approach 2 from the left side and the right side, both of those limits agree, and our answer would be 1. So the limit as x approaches 2 of the function f would be 1. Number 10, we have the absolute value of x over x. Okay, you may be able to graph this without a calculator, you may not. If you need to put this in a graphing device, go ahead and do that. But our graph here should basically, it's always going to be 1 or negative 1. The numerator will always be positive. So to the right side of 0, we're going to have a graph that looks like this. But to the left side, since the numerator will be positive and the denominator will be negative, we're going to have a graph that looks like this. So as x approaches 0 from the left, our limit is negative 1. But as x approaches 0 from the right, our limit is 1. Those two limits disagree, so this limit does not exist. Last one, and you may need to put this into a graphing device to see what this looks like. So pause the video if you need to do that now. And really zoom in on that graph if you need to. But this graph's going to kind of jump back and forth It looks something like this. Okay, this is not a great representation of what this graph would look like. If you want to zoom in on your graphing calculator, it would be a lot better than what I have here. But what this graph is doing is something we call oscillating around x equals 0. Okay, and oscillation, we'll learn very shortly here, is one of the reasons why a limit would not exist. So at 0, this limit does not exist. Okay, because what this is going to do here, and I can't really do this that well on the screen, is it's going to jump back and forth over and over again around 0, never really settling on a point. And obviously the y value at 0 would not exist, because if we put 1 over 0 in, we would not get a value back. So that brings us to why limits fail to exist. There are 3 reasons a limit might not exist. The first one, the function approaches a different number from the right side of C than it approaches from the left side of C. We call this a jump discontinuity. It's also called a non-removable discontinuity. We'll learn about that in future lessons. And it often happens with piecewise functions. You can see here, here's an example of one. The left side limit would be 4, the right side limit would be 3. They disagree, therefore the limit does not exist at x equals 2. The second one, f of x either increases or decreases without bound as x approaches c. Basically, we're looking at vertical asymptotes here. Okay, we call this an infinite discontinuity, which is also a non-removable discontinuity. So if you look here, here's your vertical asymptote there. So we say the limit does not exist at x equals 1. And the third one, this is what we just talked about recently here. F of x is oscillating between 2 fixed values as x approaches c. So it's jumping back and forth really, really quickly. That's what's happening here, something like cosine of 1 over x. So you'd say the limit does not exist at x equals 0 due to oscillating behavior. All right, so here we have an activity that we'll be doing in class. We looked back at a couple limits and we found that 2 of them did not exist. So let's go back to those and figure out why. The first one did not exist was number 10. So number 10 does not exist. Which reason is it? It's because the left side and the right side have different limits. So we would say example 10 does not exist due to reason number 1. The other one, number 11, does not exist, as you can see here. And that one is due to oscillating behavior. So we would say example 11 does not exist because of reason 2. 3. 2. 3. 3. My apologies. All right, lastly, we have a old AP question. The figure to the right shows the graph of the function f. Which of the following statements are true? So the first one says the limit at x approaches 2 from the left side of the function and the value of y at 2 are the same. So let's take a look at that. So the limit as x approaches 2 from the left, that would be negative 1. The y value at 2 would also be negative 1. So does negative 1 equal negative 1? It sure does. So 1 is definitely true. Let's take a look at 2. It says the limit as x approaches 6 from the left and the limit as x approaches 6 from the right are the same. Let's look at our graph. From the left, the limit is negative 1. From the right, the limit is negative 1. Don't worry about this y value here. It means nothing. The left-hand limit is negative 1. The right-hand limit is also negative 1. Those are true. Number 2 is true. In the third statement, the limit as x approaches 6 and the y value at 6 are the same. All right, so we just said the limit as x approaches 6 is negative 1, right? So there's your limit. The y value is -3. Those are clearly not the same. So this would be -1, this would be 3. 3 is not true. So our answer is 1 and 2, which is C. All right, that is it for today's lesson. Thanks for checking in, and we will see you next time.